Hey everyone, Mr. Newman here, and today we're going to learn about a new way to solve quadratic equations. Let's just recap the three ways we already know how to solve quadratic equations before we get started on the new one. First of all, we know how to solve equations by taking square roots. And what that looks like is this first step right here. I got the example. You get the whatever it is squared by itself, and you do that square root right there. That's the big step, the big key. When anytime to undo a square, you do a square root. Make sure you have your plus and minus, we remember that, and you solve it and get x by itself. Advantages are it's pretty fast as far as solving these things go. It's straightforward, and I say it's straightforward because it's very similar to how you solve for x in other equations. You're just getting x by itself. It's the same thing. You're adding to undo subtraction, you're dividing to undo multiplication, etc., etc. So that's why it's nice. One downside is it can only solve certain equations. For example, you can't solve this equation down here. The main reason is because of that 3x right there. When you try to get x squared by itself to square root it, that x there, you just can't square root it and it gets in the way, and you just can't solve it by taking the square root. So we also know this other way is solving by factoring, and I'm going to take that example we can't solve by using the square root, and we're going to solve it by factoring. Now I don't mean to imply that anything you can't square root you can factor. You know, there are things that you can square root that you can't factor as easily. So that first equation is much easier to take the square root rather than try to solve by factoring. But the key here is we factor, and this is kind of funny because it's different than how we solve most equations, because we're setting the equation equal to 0, and we're leaving all the variables and all the constants on one side, and then we're setting each part equal to 0. So x plus 2 equals 0 and x plus 1 equals 0, and you guys can see how we finish that is by solving each of those individual equations. So it's a little weird that we factor it first and then set each of those equal to 0. But it can also be fast. It is also fairly fast as far as these goes. And another advantage is you can actually use this method to build equations if you want specific roots. So for example, let's say I need the roots of -2 and -1. I want that to be where my parabola intersects the x-axis. Well, I know that x plus 2 and x plus 1 have to be the factors, so I can write those two down and multiply them and get out a quadratic equation that has exactly those roots. So we're going to be doing some of that later, but that is another advantage of solving by factoring. A disadvantage, however, is that some equations can't be factored. For example, right down here, this equation, there's no number that multiplies, or no pair of numbers that you can think of, no integers, that multiply to 2 and add up to 4. It just can't happen because the only factors of 2 are 1 and 2, and they don't add up to 4. So the third way that we so far have for solving these is to solve by graphing. And if you graph this equation that we can't factor right here, you notice that you can either use a TI calculator or Desmos. Notice that it gives us the two roots, or the solutions. Those are the x-intercepts of the graph. And you can click on them in Desmos, and it's a little more cumbersome on the TI, but you can find those, and you get that -3.414 and -0.586 ... The problem, or the advantage is you can see the parabola, and it shows, and you can use the graph, and it's a fairly safe way of calculating it. The downside is it's not an exact answer, and you have to have a calculator. When I say exact, I mean like the square root of 3. If, instead of saying the square root of 3, your calculator is not going to tell you the square root of 3. It's going to tell you 1 point something something something, okay? And you have to have a calculator for it. So this leads us to our last way of solving these equations is using the formula. There is actually a formula that if you have your quadratic equation set up in a certain way, you can plug them into the formula and it will give you the roots. Mr. Newman, why haven't you showed us this before? Well, it's got to be set up in a certain way, but this is a fairly straightforward way of solving these. So first off, let's talk about what it has to look like. It must be in standard form. That means the x squared term has to be first, then the x term, then the constant, or the one without an x. All right, and it has to be equal to 0. All right, if it's not equal to 0, we cannot solve it. So standard form. The next step for using this is we're going to identify what a, b, and c are. A is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. Then we're going to substitute those a, b, and c into this quadratic formula here. Now, what do I mean by x equals? I mean that as long as that equation up above is equal to 0, x equals the two solutions. Now I say two solutions because of the plus or minus. Remember, and we'll look at this in a little bit. The plus gives one solution, the minus gives another solution. And the quadratic formula gives you the zeros. That's also known as the solutions, that's also known as the x-intercepts. Remember that all those three things are the same. So here's our example. 0 equals x squared plus 4x plus 2. It is in standard form because the x squared term is first, the x squared is second, and the constant is third. And we need to see, okay, what is a, b, and c? What are our a, b, and c? Well, remember, if there's no number in front of a variable, you can think of the number 1 as the number in front, since 1 times anything is itself. So 1 is actually our a. 1 equals a. B is the number in front of the x term, so that's 4, and c is the number at the end, the constant. Now that we have a, b, and c, we're just going to plug them into the quadratic formula. So notice when I'm doing this, I'm putting b in there for the 4. I'm going to use parentheses every time I plug in a variable, and that's really important because, especially when you get to having some negatives, the negatives can trip you up if you're not very careful. So I'm going to ask you to always put parentheses around every variable you plug in. So I put a parentheses around 4. I put another parentheses around 4 because it's b squared, 4 squared, minus 4 times a, which is 1, times c, which is 2. And all of that divided by 2 times a, which is 1. Now comes the fact of simplifying it. I always like to simplify what's inside the square root first. And you can use a calculator for this part because those are just numbers. So negative 4 plus or minus, let's see, 4 squared is 16. 4 times 2 times 1 is, or 4 times 1 times 2 is 8. And we divide that by 2 times 1, which is 2. So notice I'm simplifying this in pieces. It's really important that you follow your order of operations here. So you need to do the things inside of the square root before you do anything to the square root. Now, negative 4 plus or minus the square root of 16 minus 8, which is 8, all divided by 2. And we can actually simplify the square root of 8. Now I'm going to show you how to do this, all right? Over here on the left, the square root of 8 is the square root of 4 times the square root of 2. And I chose 4 because that's a perfect square, and the square root of 4 is 2. So the square root of 8 is the same as 2 root 2, or 2 times the square root of 2. So watch out for simplifying those. This is the only one we're going to do like this for a while, but we're going to learn that again and have to simplify those. Right down here, so we have negative 4 plus or minus 2 root 2 all over 2. I can actually divide out a 2 from the top and the bottom of that equation. The reason we can divide it out of the top is because you can factor out the GCF of 2 between those two terms. So I factor those out, and all I'm left with is negative 2 plus or minus the square root of 2. Those are my solutions. One solution is the negative 2 plus root 2, the other one is negative 2 minus root 2. So let's do some other examples here to get some more practice. On the back, A is going to be 1 again, B is 3, and C is 2. We're going to plug this in, so negative 3 plus or minus 3 squared minus 4 times 1 times 2, all over 2 times 1. Notice I just took the formula from the front of your sheet and plugged them in. If you want to write down the formula again somewhere up here, feel free to. That way you can reference it. And when I simplify this, you can actually type in, inside that square root, you could type in 3 squared minus 4 times 1 times 2 all in a calculator. But I'm going to do it step by step a little bit more. So you can see that all of that becomes 1. Now the square root of 1 is 1, so that's negative 3 plus or minus 1 over 2. At this point, I'm actually, since I was able to take the square root, I'm going to write down both of these solutions. So one solution is negative 3 plus 1 over 2, and the other solution is negative 3 minus 1 over 2. So we do that, we simplify that, negative 2 over 2 is negative 1, and negative 4 over 2 is negative 2. Notice that these two solutions are the same as the example on the front. It's the factoring example. So I just wanted to do this to show you, yes, if you can solve it using factoring, you can also solve it, as long as it's in standard form, you can also solve it by using the quadratic formula. In fact, all of these, as long as you put them into standard form, can be solved using the quadratic formula. For this next one, I just want to remind you guys that this must be in standard form. Notice it is not equal to 0, so we've got to set it equal to 0. In order to do that, we can't just change the 5 to 0, but we can subtract 5 from both sides. So let's subtract 5 from both sides. That gives us 2x squared minus 3x minus 20 equals 0. 2 is our A, negative 3 is our B, and negative 20 is our C. Now this is where it gets really important that we put these in parentheses, because as you're going to see, that first thing, negative B, is actually negative 3, or the opposite of negative 3. It's very easy to forget both of those negatives or if you do not write the parentheses. One of the negatives comes from the formula, the other negative comes from B. So plus or minus the square root of b squared minus 4ac all over 2 times a. And when we negative 3, well, then opposite of a negative is a positive, so 3 plus or minus the square root of negative 3 squared is positive 9. That's another place where if you don't have the parentheses, a lot of people will write negative 9 instead. And we get 160 when we multiply all of that. A negative times a negative is a positive, so it's plus 160, all divided by 4. And 160 plus 9 is 169, which is 13 squared. So we can square root 169, and we get this, which we're going to break into 2 equations, 3 plus 13 over 4 and 3 minus 13 over 4. 3 plus 13 over 4 becomes 4, and 3 minus 13 over 4 becomes negative 5/2, or negative 2.5. Once again, you can type all of this right here into a calculator. You just need to make sure you type the plus and the minus, and the calculator will simplify it for you as long as you type it in correctly. But you have to be very careful with how you type it in, because if you type in one wrong parentheses or one wrong negative, it can change the entire answer. So those are our 2 solutions. All right, for these last 2 problems, A is 1, B is 10, C is negative 24. So we're going to write this into the quadratic formula. Negative 10 plus or minus the square root of 196 all over 2. 196 is 14 squared, so we get negative 10 plus or minus 14 over 2. This becomes 2 equations. One of those equations becomes 2, the other one becomes negative 14, so those are our 2 solutions, 2 and negative 14. Go ahead and try this last one on your own. All right, did you figure it out? Here's A, B, and C. Remember, if you don't get these correct, please go back and correct your answer. That way I know you are paying attention to the video in addition to trying the work on your own. Divide all of that by that, 2 times 2. When we simplify this, we get 3, positive 3 this time, plus or minus the square root of 49, which is a perfect square again. That's 7 squared. So 3 plus or minus 7 all over 4. One equation is 3 plus 7 over 4. The other one is 3 minus 7 over 4. And that becomes 10 fourths, or 5/2 when you simplify it, or 2.5 as decimal. And the other one becomes negative 1. So those are our 2 solutions for the last one, 5/2 and negative 1. Thank you very much for watching.